In this video, we are going to design and understand one of the most important section of ESP32 board, the USB to UART and auto restart circuit. This is the circuit that allows your computer to upload code directly to the ESP32. And if the section is designed incorrectly, your ESP32 may not upload code at all. So ESP32 does not directly communicate with USB and it's use UART communication for programming. So we need a USB to UART converter IC that's convert USB signal into the serial TX and RX signals. So in this design we are using CP2102N IC. So it is a bridge for communicating the USB to UARTs. It is made by Silicon Labs. It is handle USB communication, serial communication and data conversion between PC and ESP32. Okay, so this side having the data lines coming from the data line section, that is from type C section. So we have data lines here and we have TX RX for UART pins. Okay, so here we have D plus and D minus lines, data lines, and we had 22 ohms. Okay, 22 ohms registered in series. But if I zoom in, there is 220 ohms. So you need to correct value put inside your schematic. So I just added and put 22 ohm. Okay, so here one more change is required. Okay, so 22 ohm resistance in series. These resistors helps reduce signal reflection and improve signal integrity. This is very common in USB high speed routing. So you need to put right value. Okay, that is 22 ohm. This IC is powered 3.3 volt and we use 3 capacitors. Okay, that is 10 microfarad, 1 microfarad and 0.1 microfarads. So the smaller capacitors filters the high frequency noises and the large capacitors handle the sudden current spikes. So you need to put correct value for your IC, okay, of the capacitors. Now let's understand UART communication. So TX means transmit, RX means receive. So important rule, if you are connecting TX lines for your controller, okay, so TX goes to the RX of ESP32 and RX goes to ESP32 TX. Many designers accidentally connect TX to TX and RX to RX. That prevents communication completely. These LEDs, so I just connected the LEDs. Okay, so these LEDs connected to RX and TX activity lines. When data is transmitted or received, the LED is blinking. This helps debugging that the IC is working properly and we see that the communications works properly. Now we are going to the auto restart section. So it is the auto restart section. This is what allow ESP32 automatically enter into the programming mode. So I just write the truth table. Okay, so the normal run, that's mean DTR and RTS is high. That mean ESP enable pin and ESP IO0 pins is high. And we need to going into the programming mode, that is bootloader mode. In this DTR RTS is 0, ESP enable pin is 0 and ESP IO0. Okay, it is going to the bootloader programming mode. Okay, so this is the truth table of the section of auto restart. The CP2102 provide two signals, that is DTR and RTC. These signals control ESP enable and IO0 using two transistors. The circuit automatically toggles these pins during the uploading the code. To enter the bootloader mode, GPIO 0 must low and enable pin must go to reset. The transistor network handles this automatically. This is exactly how official ESP32 boards develop. Section, that is capacitor on enable lines, that is enable lines capacitors. Okay, so this is the capacitors of enable line. It's create a small delay during the reset. That's improve reset reliability and prevent unstable startup behavior. So some common mistake beginners makes: wrong TX-RX connection, missing enable capacitor, missing pull-up resistor, incorrect transistors wirings, no common grounding. Okay, so these issue can causes upload failure, random restart ESP32 not detect. So this is how the USB to UART and auto restart circuit work in ESP32 custom PCB. In the next video I will start integration of all the section together into the final ESP32 schematic.